Hello, Professor. This demo video is part of CMPE 255 final project, and I have chosen semantic segmentation as my final project. Now, I started by creating a few Jupyter notebooks to understand and get the code right. Once that was done, I basically turned them into scripts. One is train.py and utils.py has all the utility functions. So in this Git repo, you can basically go to ankursing.cmp255 and there's this folder called final project. So there you'll find all the code related to this project. Now, this README basically has all the setup instructions and also how to use this scripts and some other details. So since I already have the code in my computer, I can show it to you. So this is the train.py file. It basically starts by loading the data, creates the model with callbacks, and train the model, and ends by logging everything. And this is the default set of parameters that it takes. So I can simply write, and for sake of simplicity, I can just run it for one epoch, and I'll change the project to default. So this will basically start training the model, and so you'll see like these are all the parameters that are used for this run, and it will make this wannabe connection and start training the model. So here I'm training it in two parts. This is stage one of the training, so hence it's quick. But after 2 rounds of training, I'll then train it for one epoch. Basically, the complete model will be trained for one epoch after 2 rounds of training of just the decoder and head. Now, I'll just pause this thing here. Now, to make it easy, I basically created a make file. So if you just say make unit, it will basically run all these commands. So it will train unit architecture with all these different backbones, ResNet 50 and efficient at B5, MITP2, and ResNext 5032 4D. And similarly for unit plus FP and PSP and MNASNet. And also there's this thing called all, and the default is also, if you just say make, it will run all the model. I've already run it, and this is how the output looks after complete training. So you'll see that it starts by printing like it's running this script, and these are the parameters, and then you'll see first 2 rounds will be just training the head and the decoder, and next 5 rounds are for training the complete model. After the training, loss, both training and validation loss are printed, and you can see the model size, you can see the parameters, you can see the number of flops used, etc. And here is some summary which is printed by weights and bytes. And this will be done for all the 19 configurations that I have. So this is about the make file that I have used. And after running it on all the complete models, like basically all of it is logged in this weights and bias dashboard, and it's public, so anyone can view it. It has 18 different configuration, and the naming convention that I have used is basically the segmentation architecture underscore followed by the backbone. So all the details can be found here. One can also see the details. So say for example, you are just interested in BSPNet, sorry, one family of the model, you can just hide all the other. So you can just look at the loss from this. Now, these are not very important, but your training loss is something that you can keep an eye on. And another loss would be your validation loss. So these are the validation loss for each of the models. Another interesting thing that one can do is look at the input and outputs generated. So here are the outputs generated by these models. So this is the ground truth, this is the prediction, and this was the input image used. Now, along with this, I've also created a table which basically has all these model names on the left and these metrics as the columns. So the green ones are the best, like for each column, what is the best value, and the dark red is the for each column, what is the worst value. So this table can be used to understand and interpret the training process, since there are like around 18 configurations and you have like around 6 metrics to track. So this visualization can help a lot. One can also like apply filters and sort them based on any of the features. So these are all the things that I have done as part of this project, and all these things is available in the Git repo, and one can simply uh, clone it and cd into the uh, repo and find it. Yes, and if you directly want to like run everything, you can just use make. But before that, you will have to make sure you have make installed in your system, and also make sure that the Anaconda environment is set up and is active. Just once you're done with that, you are good to like train the models. And this is the output. These are the results. I have also, after analyzing this table, I have found a few insights, and these insights are available here. And towards the end, there are some details about how to integrate SMP with FastAI. And here are some references that I have used. Thank you.